Hello everyone, a very good morning to you all. I hope you all are doing well. Yes, I'm Pooja, your science teacher from Vistaslearning. I welcome you all for Vistaslearning. So let us wait a minute, let everybody join. I hope you all are doing well on this morning. And in that time, while everybody is joining, let us try to understand then what we were talking about. What we were talking about, you all are knowing, right? In our previous sessions, we had discussed about the many topics. And if you haven't watched our previous videos, go ahead and subscribe to our channels and also share the videos along with your friends and family. And also you can like it if you like our videos. Yes. So I hope you all have subscribed to our channel, right? Yes. So in our previous session, we were talking about the 8th standard science subject, that is the 4th chapter, materials, metals and non-metals, right? Yes, I hope you all remember the different topics that we all had discussed in our previous chapters. Okay, we will go into the topic what we were talking about, and also we will continue our discussion into what and all the other things we are going to learn in this chapter. So let us wait a minute, let everybody join by that time. Okay then, so what we were talking about? Yes, as you all can see, we were talking about the materials as metals and non-metals, right? Yes, we were talking about this topic. In this, what and all we had learned in our previous sessions? Yes, we were talking about what are the different physical properties of our metals and non-metals. How can we differentiate between metals and non-metals, right? And also we learned about how there are many different chemical properties of our metals and non-metals, how metal reacts with the different materials, say it could be water, air, or it is an oxygen, how metals react with all these, and also how non-metals react with oxygen, water, air and everything. We had discussed about all these topics, right? Yes. And then what are the topics that we all spoke about? Yes, under chemical property, when we were talking about the rusting of iron, right? That is one of the reaction our metals are undergoing when they are reacting with oxygen. Yes, the iron, which is a metal, it will react with the moisture content, the water present in the atmosphere, and also the air which is there in the atmosphere, right? Yes, that is how actually our rust is formed. We were talking about all of this, right? I hope you all remember how rust is formed, and also we generalized the conclusion saying that the metallic oxides are basically basic in nature. Because you all know, right? We did a small activity. We took the rust powder, we dissolved it in the water and then checked the solution for whether it is acidic or basic in nature. Yes, right? Yes. So in that we got to know that even the magnesium oxides, the many metal oxides, when they are reacting with oxygen, when many metals reacting with oxygen, we found out that metallic oxides are generally basic in nature. And also we understood that how non-metals also react, and also how other metals reacts with water. You all remember the nice picture I showed you all regarding the sodium? How sodium reacts vigorously with water? Yes, that is why we will not store the sodium in water. Where do we store our sodium in? This is a question for you all. You all have to answer me. Where do we store sodium? Because we got to know in an experiment that it reacts vigorously with water, right? Yes. Then where are we storing? I'm waiting for all of your answers. Okay, let me tell you all. The answer is we store sodium in kerosene. Yes, because that does not react with kerosene much. Yes, and also we learned about how phosphorus is stored, right? One of a non-metal. How does that react with water and air? It does not react much with water, but when it is exposed to air, just exposed to air, it will react vigorously in air. It catches fire, and there is a whole lot of reactions that it undergoes. That is why we make sure we'll store phosphorus in water so that there are no reactions, because when it is kept in air, it catches fire and reacts very much, right? Yes. So this is all the different topics that we all learned in our previous session. I hope you all have watched our previous session. If not, go ahead and watch our all other video sessions. And in today's session, we will be talking about the chemical properties of the metals and non-metals itself. That is, but we will be talking about how our metals and non-metals are reacting with acids and bases. Yes, we have learned that they react with oxygen, they react with air, water and everything. Now, let us try to understand then what are the different chemical reactions, or how our metals and non-metals are going to react with our acids and bases. There are many acid and bases through which we can conduct this particular experiment and learn what are the different chemical properties. These are not going to be very difficult, because as I'm telling, there are acids, bases, chemical reactions. Not at all difficult. It is all very simple. A few common chemical reactions that are all are happening. We will try to use in experiments and try to understand how all these chemical reactions takes place. So I hope you all are ready, right? Yes, then let us go into the topic then. Yes, what is happening here? It's a vigorous reaction that is taking place, right? Yes, you all can see there is a reaction which is happening and also an equation which is popping up. Yes, whenever there is iron or any of the metals that is reacting with the hydrochloric acid, that is HCl, right? Yes. So there are such reactions happening. As you all can see, there are bubble formations. So there might be a gas which is being generating in a chemical reaction. So let us try to understand then what is it? How is this happening? So we are going to learn about the reaction with acids, as I said. Yes, here also I am showing one more example. Previously, in this particular thing, you saw that there is iron or zinc or many other metals which are reacting with hydrochloric acid. And see this reaction? Oh, look at that, how nicely it is reacting with hydrochloric acid. Yes, here magnesium is the element that we all are using in the hydrochloric acid solution. Just drop a piece of magnesium in hydrochloric acid. Look at that, how it is reacting. It looks so nice, right? How are they reacting? It is jumping all around, producing so much bubbles, air, gas and everything, right? Yes, this is how actually our metals react. Whenever there is an acid, you are having an acid, you put any of the metals into them, and this is how they react. Like example, let us try to understand what is happening here. We saw that there is a zinc or iron or magnesium. We are going to put all those elements in the hydrochloric acid solution. Yes, hydrochloric acid, you are going to put all these metals into. So whenever you want to write a reaction regarding the hydrochloric acid or the reaction of metals with acids, remember these two equations and remember these two images. You will be definitely able to write down, because there was a container which was having hydrochloric acid and you are just dropping a piece of metal into it. It reacts very much, right? Yes, as you all can see, there is a reaction happening. Yes, and that you can definitely write it down in the form of equation very easily. Yes, this is actually one of the experimental setup. Let me explain you all how does this actually happens. So as I said, in a test tube, we have taken a hydrochloric acid, right? Yes, I hope you all are able to see this particular diagram. Yes, as I can see, Ashta is joined. Good morning, Ashta. Priyanka is also joined. Good morning, Priyanka. Atulya is also joined. Good morning, Atulya. Okay, so all of you, I hope you all are understanding that this is the experimental setup that we are going to use to understand how our metals are going to react with acids. Yes, so as I said, there's a test tube. In that, we have taken hydrochloric acid. Into that, we are dropping a zinc granule, a small piece of zinc metal take it and drop it in that hydrochloric acid. And as you all can see, through a help of a glass tube, we are making sure whatever the outcome, whatever the gas which is being produced in that reaction, because I just now showed you, if there is a hydrochloric acid, you drop any metal into it, it starts reacting vigorously. It produces gas and bubbles and everything, right? Yes. So we make sure that whatever the gas is being generated, that is going through the soap solution. With the help of the glass tube, we make sure that is going to the soap solution. And from that, as you all can see from the soap solution, as the gas is going out, it is moving out, it forms a bubble type of thing and it makes sound, right? You all might have seen whenever, when you all are playing with the soap solution, whenever you go and blow, it will make sound, right, with a bubble. Yes. So that is how the gas is trying to come out of the solution as the form of bubble and air. So what are we going to do now? We will take a matchstick, burn it and keep it near that opening. Wherever the gas is trying to move out, the bubble is trying to come out. So take a matchstick, burn it and just go and keep it there. You will hear that the gas is coming out and it is burning with a pop sound. Yes. So what happens here, the reaction is happening. Whatever the gas which has been generated, it is trying to go out. So whenever you are trying to place a matchstick which is burning there, it reacts with that and it comes out in the form of a pop sound. Yes, it makes a pop sound. You all might have heard this bubble sound popping, right? Yes, in the same way. And as I can see, Chiranjeevi is joined. Good morning, Chiranjeevi. Maruti is joined. Good morning, Maruti. Okay, so then let us try to understand. I hope you all have understood what is the experiment here, right? Yes, the gas actually comes out with a pop sound. So how nice is that to hear that sound and all, right? Whenever you are doing any experiments, this is how science is actually very fun. Isn't science fun? Yes, I like all these experiments because here there are so many reactions, as you all can see. There is pop sounds our metals are giving when they react with acids. Why not? There is music, there you all can see that the nice interactions. Yes, this is really fun. Even our reactions are not so difficult. You can learn them in a very fun way, right? If you understand them, what is happening, it is going to be very easy. Yes. Now that we have understood that the gas is coming out with a pop sound. Yes, as you all can see, metal reacts with acids and produce hydrogen gas that burns with a pop sound. Yes, what is the gas that is generated there and then? It is the hydrogen gas, because we know we are using hydrochloric acid and also any of the metal. In this case, it is the zinc metal, right? Yes, whenever it is reacting, the metals reacting with the acids, they are going to produce the hydrogen gas. So I hope you all will remember this point. This hydrogen gas is coming out of the soap solution. Whenever you try to have a matchstick, burning matchstick near to the mouth of that soap solution where the gas is escaping, you hear a pop sound. Yes. So then what about our nonmetals? Try to put any of the nonmetals into this particular hydrochloric acid. They do not react. So if you take a hydrochloric acid, pour any of the nonmetals, say sulfur, it doesn't react. You will not see any of these chemical reactions happening or any gas which is coming out with a pop sound. Yes. So our nonmetals generally do not react. Yes. Now, I hope you all have understood about these points. Then let us try to move into the next one. Let us try to do a small activity. As I said, take a small beaker and then put 50 ml of water into it. And you can drop this particular metals, as I say, into them and observe the reactions. The first one is the magnesium. I'm saying it is a metal. Yes, it is a metal because whenever you drop the magnesium into hydrochloric acid, that there is the hydrogen gas which is generated, which comes out with a pop sound. And whatever is the next element, that is the aluminium. Yes, we all know that aluminium is also a metal. The same type of things happen here also. There is the hydrogen gas which is being generated when there is a reaction happening. But what about our nonmetals? like charcoal. If you go and put the charcoal in any of the acids or acid solution, hydrochloric acid or sulfuric acid, what happens? It doesn't react, right? Yes, it will not react because it is a non-metal. They do not react with our acids. Yes. And one more example could be like the sulfur. If you have sulfur, as I said just now before, if you place this particular element in any of the acid, they generally do not react. So I hope you all have understood about the different reactions our metals and non-metals are going through when it comes to the reaction with acids. Then let us try to understand then what are the reaction with bases. Yes, if there is any experiment, it is very easy to understand, right? Because if there is such experiments, you do this, and we'll try to learn and see the whatever the change is happening, we remember fast, right? Yes, if we have done something, we'll tend to remember that fast. That is why we all tell, right? Instead of reading 10 and 100 times, try to write it down at 1 or 2, 3 times. Because you have done the work there, you will remember well. Yes. So that is how. Let us try to have a check with one of the experiment and understand how our metals are reacting with the bases. Yes, you all can see there are 5 beakers. Yes, in this 5 beakers, let us name them as A, B, C, D and E. We have named all of it, and into this particular, see the first image, that is image A. In that, there are 5 beakers. You're going to make sure you're putting the 50 ml of water or 100 ml of water into this particular beakers which we are having, and you will be going to place the metals in all these beakers, and let us try to understand then what are we going to put in each of the beakers. What is the acid that we are going to put? What is the element that we are going to put? The metal that we are going to put. Yes, in beaker A, we are going to put the copper sulphate, CuSO4, along with the zinc metal. So I hope you all have understood. In A, we have copper sulphate and also the zinc. And in the next beaker, that is beaker B, we are putting copper sulphate along with an iron nail. We all know the iron nail, right? In a day-to-day basis, we are going to use. So put the copper sulphate and an iron nail in your second beaker. And in our beaker C, we are going to put the zinc sulphate and the copper turnings. We will be all having copper wirings in our home, right? Yes. So we are going to put the zinc sulphate and also the copper turnings into the third beaker. Yes. In our next beaker, we are putting the iron sulphate, FeSO4 and the copper turnings. Yes. And in our last beaker, we are putting the zinc sulphate and also the iron nail. So these are the 5 beakers where we have kept so many things. So in this, you all have understood that in different beakers, we have different things which we have kept. Yes. In what happens here, there you have taken up 5 beakers, named them and kept all those acids and also those elements, the metals as their copper, aluminium, iron, zinc metals, we have placed in all of it, close it and keep it somewhere. Let us have a check after some time what might have been happened here. What has happened here? As you all can see, these are the different things that we all have put in our different beakers, right? So what has happened here? So in beaker A, zinc replaces the copper from the copper sulphate. Yes, this is the reaction which is happening here. Yes, what happened? As I said, in our first beaker, we had our the things which we had kept, the acid and the metal. So here, the zinc is good because the metal which you kept in beaker A is zinc, right? I hope you all remember. Yes. So zinc is going to replace the copper because in our beaker A, we had copper sulphate and also zinc. Zinc is replacing copper. So the blue color solution which we had got by mixing copper sulphate and zinc is now turned into, it is not at all a blue color solution. what happens? There will be a red color copper formation will be there in the bottom of that particular container or the glass jar which we were using. So what happens? Zinc is going to replace copper in that particular solution. Yes, these are called as the displacement reactions. Yes, because very simple as that, zinc is going to replace copper. That is why these are displacement reactions. So I hope you all understood this. Yes, so we all have understood that there is a reaction which is happening. Zinc is going to replace this particular copper. And similarly, there are another four containers which we were doing the experiment with. What happened to them then? Yes. So that is why, as I was telling you, the blue color of the copper sulphate disappears and a powdery red mass of copper is deposited at the bottom of the beaker. And then what is the reaction that is going to happen? We have to write down a chemical reaction, right? It is very simple. Now that we all have understood what is the chemical reaction taking place, there was zinc, there was copper sulphate, and zinc is just going to replace the copper. Very simple equation. Yes, zinc we had, Zn we represented, and CuSO4, that is the copper sulphate, those two are reacting together where zinc is replacing copper. That is why, very simple equation, just replace zinc from copper. That is it. And we are getting the zinc sulphate and the copper as the two different reactions which are happening in our experiment that we all just now learned. So this is the simple example. Similarly, you can definitely write an equation for our second beaker. What did we have in our second beaker? Where we had copper sulphate and also the iron nail, right? Yes, similarly, you can write this equation where iron is going to replace copper. Yes, now that we all have understood about the first two beakers, let us try to understand then what happens to the others. What are they sitting and doing? Yes, why there is no change in beaker C, D and E? What is happening to them? Why are they not reacting? Are they not interested in doing any chemical reaction? Nothing like that, right? Because it is actually science. Here, nothing like a magic happens, right? Everything has certain rules. They follow certain rules, regulations, and that is how they all take place. So then why are they not reacting? Let us try to understand then. Why are they not reacting? Why there is no change in those beakers? Only these beakers are going to change. There are chemical reactions happening. Yes, let us try to understand then what might be the reason. Yes, a more reactive metal can replace a less reactive metal, but a less reactive one cannot replace a more reactive one. This is actually the rule that all these five beakers are going to follow, the scientific reason that they are going to follow in order to make sure that they should react or they should not react. So what happened? We all understand that zinc is going to replace copper, right? In our previous discussion when we are doing right now. Yes. So zinc is a very reactive metal that is going to replace copper. But when it comes to copper or iron, they are not more reactive compared to zinc. Zinc is very reactive. When it compared to copper and iron, they are not more such reactive ones. That is why they cannot replace a zinc in the reaction. Only zinc can replace these particular elements in the reaction. That is why in beakers C, D and E, there are no such reactions that are happening because zinc is more reactive. It will not make sure that you come and replace me. Yes, zinc is like very strong guy which you all have. Even if you're trying to push it, it is like, no, I'm stronger than you. I'm not gonna go. Yes, that is how zinc actually reacts. Yes, but zinc is very strong. It will go to copper sulphate and tell, okay, I'm very strong. I can pull you out. I'm more reactive. Yes, and it will separate zinc and it will go and sit with the copper sulphate. It will become a zinc sulphate and copper will be separated. That is how actually zinc is more reactive compared to copper and iron. So there are no changes in other beaker, whereas there are changes in our first and second beakers. So I hope you all have understood about the different reaction of elements with bases, non-elements also with bases. So then let us try to understand then what are the uses. So now that we have understood what are the different reactions with bases, the displacement reaction with a small experiments, right? Now let us try to understand what are the uses then. Yes, the uses of metals. We all know that metals are used in multiple places in making many things, right? As you all can see, just this particular bridge, which is made up of iron, the metal. Yes, they make use of different metals in the construction of bridges and also many other things. As one such example is this, there in this picture itself, it is made use in the making of bridges. And what is the next use then? Yes, you all can see such a nice aeroplane there. Yes, they are made used in the preparation of aeroplanes, automobiles, and many other things. And also they are made use in the formation of satellites. Yes, you all can see there is a satellite. Yes, they are used in the preparation of satellites, automobiles, aeroplanes, and not only that, in many different machineries. We all know we are going to use metals, right? And also in not only that, in kitchen utensils, we will be using many of the metals, and also in making of trains and many other automobiles, cars, we make use of metals, and also in making of bottles, we make use of metals. So metal is found in most of the places where we make use of them in making of these so many things. Yes, they are used in making of aeroplane, satellites, utensils, water boilers, and many other things. Yes, and now that we have understood what are the uses of metals, let us try to understand then where are our non-metals used. Yes, they also have plenty of uses. Let us try to understand them one by one. Yes, you all can see that there is a man who's putting the fertilizers into the plants, right? Yes, that is where they basically use the non-metals. You all have learned in our first chapter, right? Where we make use of phosphorus, nitrogen, and many other things. Yes, the non-metals are used in fertilizers in order to make sure we'll increase the soil fertility and also the plant growth is done well. And also you all can see a burning of cracker behind me, right? Yes, these particular non-metals like lead, iron, and many heavy metals are used in the preparation of crackers because they are actually, as I said, they're heavy, they're very useful in the making of crackers. Yes, they are used in fertilizers. The non-metals are used in fertilizers in the preparation of crackers and also in many other places. Yes, as I said, they were used in fertilizers to enhance the growth of plants and they are used in the water purification process. Yes, we all know that whenever there is a water treatment which is happening, they're trying to clean the water, purify the water. We make use of which element or which non-metal? It is chlorine, right? Yes. This is actually the non-metal which we are using in the purification of water. And non-metals are used in a purple colored solution which is applied on our wounds as an antiseptic. Yes, non-metals are used as an antiseptic. You all might have seen that yellow color bottle. What do we call it as? That is the tincture we all call it, right? Yes, that is the tincture of iodine that we all gonna use because whenever we are got hurt, there is a wound. Whenever you go to hospital, they make sure they have to clean the wound, right? They apply this tincture first. Yes, actually this iodine actually is used in the preparation of this particular antiseptic that is used as an antiseptic. That is the tincture of iodine is used as an antiseptic in many of the medical fields. And the next one, as I said, they are used in the preparation of crackers. So I hope you all have understood what are the different uses of metals and also the non-metals. And that's it for today from my end. And with this, we will come to the end of this particular chapter where we were discussing about the metals and non-metals. We learnt about many physical properties, many chemical properties, and also what are the different uses of those particular metals and non-metals. So go back and revise into all of these topics. Go back and watch our videos, the previous sessions, and try to learn and understand what are the different topics. If there is any such doubts or clarifications which you all have, you can definitely reach out to us at our website. We will be always there to help you all. So go back and subscribe to our channel, and don't forget to press the bell icon, right? And you will be notified for all our new videos and chapters. So in our upcoming session, let us try to move on to a whole new chapter again and try to understand what are they. So until then, keep watching, be learning, and keep learning. Thank you all.